To experiment with catching errors, we need an error to catch. Let's start with something simple, trying to convert a non-numeric string to an integer. So here on line 1, we define a variable called myString and give it the value of a string. This string is not a number. Kind of on the nose, but we'll go with it. Needless to say, we can't convert that string into a number because it isn't a number. So what happens when we try? So on line 3, we create a variable called myInt and set it equal to the output of the function int, which converts myString into an integer. And sure enough, as we expected, that generates an error. Specifically, the error is on line 3 as expected, and it's a value error. It says invalid literal for int with base 10. That's just a fancy way for the computer to say, I don't know how to convert that to an integer. Note that line 2 still ran. We still see the output from any code that ran before the error was encountered. Note also that line 5 does not print, because line 5 never runs. That's because the error arose on line 3, and so the code stopped running at line 3. Note that when you do this, you might actually find that the output is a little bit jumbled. You might find that the output from the lines of code before the error was encountered is actually interspersed somewhere inside of the error message. That's because of some complicated details about the way Python actually does this. Don't worry too much about it. You can usually kind of see the order in which the error must have arisen. So for now, all we want to do is prevent our code from crashing when it tries, notice why it's called a try statement, to perform this type of conversion. However, Python is not a language that allows a try without catching something, or alternatively a finally, but we'll get to that later. So we need to include both the try and the catch. So we'll include the catch here, but we'll talk more extensively about it in the next section. So here's the revision to this code. As before, on line 1, we create a variable called myString and set it equal to the value this string is not a number. But what we've done is added a try block starting on line 3. What this says is to attempt the code inside of this block, but if an error is encountered, don't crash altogether. Stop running that particular block, but then keep running with what comes next. That's why it's called a try block. It tries to run this code, but if it fails, it knows how to recover. So initially, execution continues as we expect. It runs line 4, and line 4 prints the string, converting myString to int. It then tries to run line 5, but as we saw before, line 5 generates an error. Because the error is generated right here, at that point, the try block tells the execution to jump to the catch. Here, catch is defined by the Java keyword except. The code would then execute whatever is inside that except block, which means in this case we get to see a reason why we might use the keyword for pass if we just want to ignore any error. Don't ever do that in the real world though. Then once these two control structures, this try and this except, are done, execution continues as normal, and so line 10 is actually run. And sure enough we see done in our output. Notice though that line 6 was never run. Line 6 was skipped because after the computer encountered an error on line 5, it kicked execution from inside the try block down into the except block. It knew to do that because of those two keywords. The keyword try tells the computer that for all the indented code that follows, don't crash if you encounter an error. Instead, jump to wherever you see the keyword for except. The keyword except tells the computer where to go if it encounters an error somewhere in that block. Now, if no error was encountered, then the except block will never run. It's kind of like an else in that way, but we'll get to that more in a second. The important thing is that we never resolved the error in line 5, and yet we prevented the program from crashing when it encountered that error by catching that error. And we were only able to catch that error by explicitly telling the computer that this block of code was to be tried. Try tells the computer it's okay to fail.